Look at any rainbow in a book or on a flag. Count the colors. You get 7. Red, orange, yellow, green, blue, indigo, violet. That list feels fixed. It feels as solid as a law of nature. But it was not always 7. And that is where the story starts to bend. The deeper you go into the history of color, the stranger it gets. 7 was not simply found in nature. 7 was selected. That choice came from Isaac Newton. He is the man tied forever to the Prism experiment. A beam of sunlight passed through glass. White light spread into a visible spectrum. Every school book repeats that scene. But Newton's first notes did not describe 7 colors. They described 5. Red, yellow, green, blue, violet. That matters. A rainbow is not made of neat painted stripes. It is a continuous flow. The eye sees one hue slide into the next. So the moment you divide that flow into separate bands, you make a judgment call. Newton first made that call with 5 bands. Later he revised it. He inserted orange between red and yellow. He inserted indigo between blue and violet. 5 became 7. And 7 is what history kept. 7 entered textbooks. 7 became classroom truth. 7 came to sound inevitable. But Newton did not choose 7 because optics demanded it. He chose 7 because harmony demanded it. Newton wrote openly about this analogy. He wanted the spectrum to mirror the musical scale. 7 notes, 7 colors. To him, the universe ran on repeating numerical patterns. Light and sound were not separate things in spirit. They were different expressions of one deep order. 5 broke that pattern. 7 preserved it. This is easy to miss today because Newton is usually presented as pure reason. The image is familiar. The founder of modern physics, the master of gravity, motion and light. That image is incomplete. Newton also spent vast amounts of time on alchemy, theology, biblical chronology, and sacred number patterns. In fact, historians have long noted that he wrote more on religion and alchemy than on physics. After his death, much of that side of him stayed in the shadows for generations. His scientific legacy was useful. His mystical interests were awkward. So the public image narrowed. Yet the record never vanished. It sits in notebooks, letters, and manuscripts. When you read those records, the reasoning behind the 7-color rainbow looks far less modern than people expect. It belongs to an older habit of thought. The same habit that gave special weight to 7 planets in ancient astronomy, 7 days in sacred time, and 7 stages or levels in many symbolic systems. So 7 was not a neutral count. It carried cultural force. It carried spiritual prestige. And once Newton published that version, his authority did the rest. A flexible visual experience hardened into a standard list. By the way, if details like this fascinate you, subscribe to the channel. We dig into the hidden choices that later got dressed up as facts. Before Newton fixed the rainbow at 7, people described it in very different ways. Aristotle spoke of 3 colors, and in some readings 4. Medieval writers, such as Robert Grosseteste, discussed light and color without locking the rainbow into one final number. The same pattern appears beyond Europe. Chinese traditions, Indian traditions, and Islamic scholars all approached color through different frameworks. There was no universal agreement. The rainbow was understood as continuous, and each culture cut that continuity in its own way. That alone is revealing. It shows that color categories are not just about the eye. They are also about language, philosophy, and habit. But then an even stranger pattern appears. In some older traditions, the rainbow does not stop at 7. It reaches 8. This 8th color does not fit neatly into the modern school chart. It is not simply another clean band between 2 others. It appears near the edge of visibility. In some Greek discussions, scholars point to a difficult color term that has been debated for centuries. It refers to something dark, luminous, and unstable. Not quite blue. Not quite violet. Not black either. Indian sources describe a similar threshold shade in discussions of radiant or divine light. Again, the point is not a tidy extra stripe. The point is a limit experience. The deeper this goes, the clearer the pattern becomes. The 8th color was often less a hue than a boundary. It marked the place where vision strains. It marked the rim where color starts to fail. That idea sounds poetic, but modern science gives it an interesting backdrop. The visible spectrum covers wavelengths of roughly 380 to 700 nanometers. Within that range, the human visual system does not detect little natural labels inside that flow. It does not receive a built-in sign that says blue ends here and violet begins there. The brain groups continuous input into categories. Researchers often say humans can distinguish millions of colors. The exact number varies by method, but the core point stands: our color world is richly graded, not naturally split into 7 official compartments. So the 7-color model is not false, because those colors are imaginary. Red exists, blue exists, violet exists. The model is limited because its borders are chosen, not discovered. You could divide the spectrum into 5 major zones, or 8, or 12, or many more. Each system would reflect a human decision laid over a continuous physical process. And this is where the old 8-color traditions become so interesting. They were not just adding one more category. They were preserving the edge itself. In Newton's published scheme, the spectrum has clear ends. Red marks one side. Violet marks the other. Beyond them lie infrared and ultraviolet, which the eye cannot see. That framework is powerful. It is also very clean, perhaps too clean. The older 8th color seems to point at the threshold where the visible gives way to the invisible. Not a color comfortably inside the spectrum, but a color of the limit. A sign that perception has reached its border and senses something beyond it. That is a very different way to think about seeing. It treats the edge not as a cutoff, but as an event, and this pattern does not stand alone. It echoes a larger habit in intellectual history. Natural or older counts often get simplified into cleaner systems. 13 months become 12. 13 zodiac signs become 12. The rough edge gets trimmed. The awkward extra piece disappears. What remains looks elegant, stable, and official. But it may not be more true. It may only be more convenient. 13 became 12. 8 became 7. Each cut did the same thing. It removed a threshold. It erased the in-between. The 13th month once linked solar time to the moon. The 13th zodiac sign marked a passage between death and renewal. The 13th hour pointed to a shift in the body, not just on a clock face. And the 8th color marked the edge of sight itself. The place where the visible leans toward the invisible. That pattern matters. It shows up again and again. When a culture removes the threshold, the system gets simpler. It also gets flatter. It becomes easier to teach, easier to manage, but it loses contact with the messy thing it was meant to describe. The calendar drifts from the moon. The zodiac drifts from the sky. The clock drifts from lived rhythm. The spectrum drifts from perception. And that brings us back to Newton. Newton did not simply name 7 colors in the rainbow because 7 appeared in nature. He chose a very specific 7. He wanted the spectrum to mirror the musical scale. Do, re, mi, fa, sol, la, ti. 7 named notes inside the octave. 7 named colors inside the spectrum. That sounds neat. Too neat, because music does not really stop at 7. It resolves on the 8th note, the octave. The return to the first note at a higher frequency. The cycle closes there. The pattern completes there. Newton kept the 7. He dropped the return. That choice changed everything. It turned a cycle into a line. Red to violet, beginning to end. A sequence with no fold back. But human color experience does fold back. Artists have known this for centuries. That is why the color wheel is a wheel, not a strip. And here is the detail most school lessons skip. Purple and magenta do not appear as single spectral bands in the rainbow. They are not produced by one isolated wavelength. Your brain creates them when it receives input from both ends of the visible range at once, from the reddest and the most violet light. In other words, your own perception closes the loop that Newton left open. That is not a minor detail. It is the structural key. On a physical chart, the visible spectrum is often drawn as a band. In experience, color behaves more like a return. Red leans toward violet through non-spectral purples. The end approaches the beginning. The line wants to become a circle. By the way, if details like this pull you in, subscribe to the channel. This is where we follow the hidden logic behind familiar ideas. The color wheel preserves what the 7-color line suppresses. It gives a place to completion. It gives a place to return. It gives a place to the boundary where an ending meets a beginning. Newton's model did the opposite. It cut the loop. It imposed order on something more fluid than the order allowed. And once you notice that move, you start to see the same operation elsewhere. A natural process gets translated into a clean system. Then one awkward element disappears. Usually it is the element that links the system back to lived reality. The lunar month vanishes from the calendar. The threshold constellation vanishes from the zodiac. The transitional hour vanishes from timekeeping. The boundary color vanishes from the spectrum. Each deletion has a cost. Institutions rarely feel that cost. People do. What gets lost is not just a symbol. It is a kind of awareness. The feeling of transition. The sense that categories blur. The knowledge that the edge of a system may be the most important part of it. That is why the perceptual side of this matters so much. Ancient traditions that spoke of an eighth color were not necessarily making a crude mistake about optics. In many cases, they were trying to describe an experience. Modern neuroscience gives us a way to take that seriously. The visual system does not only measure wavelengths. It is highly sensitive to contrast, transition, and boundary. This is why sharp edges grab attention. This is why optical illusions work. This is why the border of a shadow often looks more vivid than the shadow itself. Your brain is built to detect change. It hunts for thresholds. So what happens at the threshold of visibility itself? At the limits of the visible spectrum, the eye does not discover a tidy label. It encounters a boundary. It reaches a point where color gives way to frequencies it cannot resolve. That boundary is real as an experience, even if it is not a separate wavelength with its own narrow slot on a chart. That is the crucial distinction. Not color as physics alone. Color as perception. Newton's 7-color model treats the rainbow as sorted data. It presents clean categories. It gives endpoints, but it says almost nothing about the felt experience of reaching those endpoints. Older 8-color traditions often did something different. They included the boundary as part of the phenomenon. They treated the edge of perception as meaningful, not accidental. That sounds strange only because we were trained to trust the categories more than the encounter. And there is another twist here. The rainbow does not truly contain 7 colors at all. It contains a continuous gradient. There are no hard lines in the sky, no cosmic labels, no natural bands stamped into light. Any division into named colors is a human decision laid over a continuum. Languages divide that continuum differently. Some cultures use fewer basic color terms. Some use more. Children learn the categories they are taught. Scientists know the spectrum is continuous. Yet the simplified school version still repeats the same 7. That should raise a question. Why this 7? Why this exact division? Why preserve a scheme shaped by analogy to music, when the underlying phenomenon never required such a count? The historical answer is awkward. Newton was not working as a modern laboratory physicist in the way textbooks imply. He was also deeply immersed in alchemy, theology, sacred proportion, and hidden correspondences. He searched for order across nature, scripture, number, and sound. For him, 7 was not just convenient. 7 was meaningful. That does not erase his brilliance. It does complicate the legend. The standard classroom story says, observation produced 7 colors. The fuller story is that observation met symbolism. And symbolism helped decide the final map. That map then hardened into doctrine. For centuries, students learned that the rainbow has 7 colors, as if the number came straight from nature itself. Rarely were they told that this count was chosen, adjusted, and culturally preserved. Rarely were they told that some earlier systems recognized 8 divisions. Rarely were they told that artists, mystics, and perceptual traditions often paid attention to the return. So the real question is not whether the rainbow secretly contains one hidden extra stripe. It does not work that way. The deeper question is what the 8th color meant, not as a narrow band of light, but as a human event. The sensation of arriving at the edge of sight, the awareness that perception has limits, the intuition that the limit itself carries information. That is not nonsense. It is a serious phenomenological claim, and parts of cognitive science now point in that direction. Perception is not passive recording. It is active construction. The brain emphasizes difference, contrast, and transition. It often makes the boundary more salient than the field. So when older traditions honored a boundary color, they may have been naming exactly that. Not a wavelength in isolation, but the experience of limit. And once that possibility opens, Newton's omission looks less innocent. It looks like a cultural preference for closed systems, for clean teaching models, for measurable segments over lived ambiguity. A line is easier than a loop. A list is easier than a threshold. 7 fixed labels are easier than admitting that the eye meets a continuum and feels its own edge, which means the lost 8th color may never have been lost from nature. it may have been lost from the story. The story we inherited favors systems that close on themselves, systems that appear complete because they remove the awkward bridge to whatever lies beyond them. But the bridge is often where the deepest meaning sits, and here that bridge may be the very moment when seeing reaches its limit and still senses more beyond it. Go outside after the next rain. Look longer than usual. Do not just count colors. Watch where one becomes another. Watch the places your eyes cannot name cleanly. Watch how the arc feels complete even where the textbook model runs out. That is where the old question returns. Not how many colors are there, but what happens at the edge, where the visible world stops pretending to be simple. Find a rainbow. Then look past the colors. Watch the outer edge, where violet thins into open sky. There is a border there. Your eyes catch it at once. Yet Newton's 7-color model says that border should not matter. But that is the strange part. You can see a final band, a threshold between color and no color, a limit where light seems to dissolve. Many older traditions treated that outer zone as real. They did not always stop at 7. In ancient systems, color often carried symbolic weight, and the full arc meant more than a neat scientific list. Newton changed that story. He presented the spectrum as 7 colors, complete and ordered. The choice looked scientific. It was not only that. He also lived in a time obsessed with sacred numbers, harmony and hidden correspondences. 7 matched musical notes. 7 matched old mystical systems. So the missing band was not exactly discovered and lost. It was seen, then ignored. By the way, if details like this catch your ear, subscribe to the channel. Here we dig into the hidden choices that shape what everyone thinks is fact. You were handed a 7-color rainbow and told it was complete. But the eye still notices the edge. And that edge keeps asking the same question. What else was edited out?